Would you know how to find a rule that proves when 5 consecutive integers have a sum divisible by 15? This is a tricky question, it's a little bit wordy, and we're going to have to start by converting some of this word into a mathematical context. And in particular, we want to focus on those 5 consecutive integers. How are we going to write that in our mathematical language? Well, one way that we could do this is by starting by saying, well, let's let the first integer be x. And then the second integer would be x plus 1, then x plus 2, x plus 3, and finally x plus 4. And this would be fine. We can do this. Generally though, and this is just a little tip, when we have consecutive number problems, often makes it slightly simpler to let our unknown quantity, x, be our middle number. The reason being, if we have x and x plus 1, x plus 2, and then x minus 1 and x minus 2, all of the minus 1s, minus 2s, plus 1s, plus 2s, they're going to cancel out. So it's going to be a little bit simpler for our final algebraic equation once we've added them all together. And this is quite common in these types of consecutive number problems, that this will make it slightly simpler than doing it this way, but both would work. So let's get rid of that for now. So we're looking for the sum of 5 consecutive integers. We've represented our 5 consecutive integers algebraically. We now need to add them together. And as you'll see, when we do add all of these 5 parts together, we just get 5x. Fantastic. So we're looking to find a rule when the 5 consecutive integers are divisible by 15. Well, what this tells us, because it's 5x, this is always going to be a multiple of 5. And that's helpful because a multiple of 15 must be a multiple of 5 and of 3. So when will our 5 consecutive integers also be a multiple of 3? Well, when x is a multiple of 3, right? If x is a multiple of 3, then this will be a multiple of 15. So what this tells us is whenever the middle number of our 5 consecutive integers is a multiple of 3, then the sum will have a factor of 5 and it will have a factor of 3. Thus, it will have a factor of 15. Let's check this. So if we did 1 plus 2 plus 3, middle number, plus 4 plus 5, well, that sum is just 6, 10, 15. That worked. What about 2 plus 3 plus 4 plus 5 plus 6? Well, we've added 1 to all of the above. The sum is going to be 20. That is not a multiple of 3. The next one would be when 6 is in the middle, so you get 4 plus 5 plus 6 plus 7 plus 8, and that is indeed 30. So it's just, we're double checking the pattern here and you can start to see exactly why this works, as well as having our proof that the middle number must be a multiple of 3. If you like that, let me know in the comments.